Hey guys, it's Mohammad Jawad from bitband.org, and in this video we're going to create a desktop application using pyqt6 in order to decrypt and encrypt our files. We can set password on our files, no matter what file is it, images, PDF file, or any other files. The app is something like this. It has a plus button here. We can select a file. I have prepared an image of Rud Khan. We select it, it shows it here. Then we can press encrypt. It asks us for a password. I set 123, retype it, and press encrypt. It wants to know where we want to save our file. I want to save it on my original file. I want to replace it. So I click on it in order to have its name here, press save. It asks me if I'm sure I want to replace it. I say yes. Then it opens the file, and we can see that this file is no longer, we can see it because the content is encrypted and it's no longer an image. It's also on my desktop where I have saved it. Now if I want to decrypt it back, I have to select it again, and you see that this image is turned into a lock, which means that this file is encrypted and we don't know what the content is. So in order to decrypt it, I press decrypt. I enter something wrong, press decrypt. It says the password is wrong. I say okay. I enter a correct password, which was 123. Press decrypt. It asks me where do I want to save it. I want to save it on my original encrypted file. I want to replace it again. I press save. It says if I'm sure I want to save it, I say yes, and then the file is reverted back. It's encrypted and we can see the content. Before creating it step by step from scratch, please subscribe and hit the like button if you haven't, and then let's get started. Okay guys, first we create a folder named MJ, for example, crypter. Okay. Open it. We open our cmd. In this directory we create a Python virtual environment with the command python-m venv. I'll name it venv. You can name it whatever you want. venv. That's right. It might take a while. Next, we activate our virtual environment. How was it on Windows? Scripts activate. Then we install pyqt6 with the command pip install pyqt6-tools. Start to download packages and install them. Now that the pyqt6 is installed, we can go to our virtual environment folder, lib folder, side packages, and pyqt6 application. Qt6 applications, then qt folder, bin, and open our designer. In order not to go this path every time we want to open our designer, I want to create a shortcut here. I create a shortcut and cut it here. Now I can click on it every time I want to open my designer. Why did I close that folder? Okay, create. Beautiful. We don't want this menu bar. Okay, let me smallize it a little bit. That's cool. We want a vertical layout. We right click on a free area on our window, not inside our layout, outside. We click on it, layout, then press layout in a grid in order to stretch our layout to be resized with the former size. That's for the responsive design of this window. Then we add a label. This label is going to be our plus button, which I showed you. Then we want a line edit. Please be here. Then we want a horizontal layout. Yep, 2 buttons. 1 and 2. I think it's okay. Let's set style. We right click on our label and press change style sheet. Yeah, we can write CSS codes here, as you know. I try to select it, Q label. I'm not a front-end developer, but yeah, I can do it, I think. And then a sharp name of my label. I want to name it what should I name? Select label. But make sure to put this select label. Let me press OK. You have to name this label that name I just said. Yep. I change it to select label in order to be able to select it in my CSS code. You could not do it, but I like clean codes. You know, you could just select it with Q label, but I like to write it clean. Then we go to style sheet again. We see that we can set, for example, font size to, for example, let me test 22 pixel. Press apply. Yep. Color, I like it to be gray. Apply. Yep. I want a border. I want it to be 2 pixels. I want it to be dashed, and the color gray. Perfect. Yeah, I don't want any style sheet again, so I press OK. I just want to change it to a plus. Better, but I want a bigger font size. I change it, let's see, 30 pixels. Apply a little more, 30 pixels. Not bad. Okay, not bad. Then I want to justify it in the center. I search here for the layout. I think, yeah, layout direction, left to right. Layout direction. No. Let's search for, what was it? Alignment. I'm sorry. Alignment, horizontal alignment. The vertical alignment is aligned via center. We want the horizontal alignment to be the same. Now it's in the middle. Beautiful. Not bad. Let me view it. Form preview. Not bad, but I want it to be like a rectangle. Okay, form preview. Beautiful. Yeah. Okay. Yeah. One thing more. I want the mouse to be, the pointer to be cursor here, not I want the cursor, what I'm talking about, the cursor to be a hand here. So I select it, search here for the cursor, and I change it to a pointing hand. Yeah. Now when we see it, you see the cursor changes into a mouse, which gives the feeling of that this is a button that we can click on it, not just a label. Okay, then I think we don't need to work on the label anymore. I think it's fine. Next thing is our line edit. I want it to be not, you know why is this here, guys? When we select a file, I want the path of that file to be written here. I don't want the user to be able to type anything here, so I want to make it disabled. I search here for enabled and unclick it. Now this is not, I think this should not be writable. Yeah, we cannot write here, but when we select the file here, the path will be written here. Okay, this button should be changed into encrypt, and this button should be changed into decrypt. That's right. And I think our UI file is ready. Yeah, not bad. Let's just change the object's name. I changed it before. We named it select label. Our line edit, we can change it to path line edit. You could name it whatever you want, but I encourage you to name something descriptive, because you in the code you have to call these objects with these names. Make it readable, descriptive, and ready to code. And I'm sorry, easy to code. Okay, here our horizontal layer does not need any name because we don't want to call it in our code, but our encrypt button needs a name. I name it encrypt button. And this guy well, what am I doing? This guy is going to be decrypt button. Okay, encrypt button, decrypt button, everything is okay. Let's test the responsive side. Let's see. Yeah, it's okay. You know, because of our layouts, this is a pretty responsive design. I think it's okay. Then let's save our design. We press save as here. Then inside of let's save it. Where was our project? It was on desktop. Yeah, MJ Crypter. Here I want to create a folder, name it assets. Inside the assets folder I want to name it make another folder and name it templates. Yeah, and I want to save my template here and name it Crypter. And .ui will be appended to it, and I press save. Now my design is ready. Let's see, assets, templates, and this is my crypter.ui file which I've just saved. Next, I try to open my VS Code in this directory. I press code dot to point to this directory. I'll wait for the VS Code to open. Here it is. It's still trying to open. Yeah. Next we create another folder here and I name it Windows. This is going to hold our Windows files, the files that actually render these UI files. Then we create a module here, name it crypter.py. We missed this R. Okay, we close this window and import sys here. Then from pyqt6 we import Qt widgets UIC in order to load our template UI file, and then our Qt core and actually Qt GUI as QTG. I want to change the name. Next we create our crypter window we inherited from qt widgets.q main window. We create the constructor init.py. Don't need these. Thank you, VS Code. Go. Not needed. Instead, I want to, catch them like this. Args and keyword arguments. And pass them to the parent. Okay. Next, we call the UIC module we just imported and call load UI. It wants the path to the UI file. I don't like to pass it here. I like to go to my, here and create a folder named utils. Inside of the utils, I want to create a module named constants. .py and create my, for example, crypter template. I have to import OS. Guys, I want to do the address. I want to get the address from os.path.join because the backslash and forward slash are different in Windows and Linux. In Linux, in order to write an address, we use backslash, if I'm not wrong. In Windows we do it like here. If you see here, these are backslashes, but in Linux we use forward slash. So in order for our app to be able to run on Windows and Linux, we have to use OS module to create the address. We cannot do it statically here. Write it statically here. So we use os.path.join. We have to have assets. Have to join. Actually, utils. No, not utils, assets. That was right. Assets, templates, and then crypter.ui. That should work, but I want to separate this templates folder. I don't want, because we are going to have many templates addresses here listed. I don't want to repeat these two a lot. I create a folder. I create another constants here. Name it templates and something like this here, but without crypter.ui. Now, instead of these two, we pass templates here. But I want to, change the name. Let's add, for example, templates address. I think this is more descriptive. And here, crypter template address. I think this is better. You can ignore doing it. I like it more. Okay, now we can pass our templates folder here, but we have to import it. We go to our from utils.constants import. let's say yeah, this guy, crypto template address, and we have to pass another argument here named self. This is the object we are working on. We get it from here. Okay, next we have to call the show method in order to render our template. Now that we have an initial setup for our templates, we can run it in our main folder. I close all of these and create a module here, and I'll name it main.py. Here we import sys and qt widgets from pyqt6. We import qt widgets. Next we have to import our crypter.py, our windows we just created. We say from where was it? It was in windows.crypter. Yeah, we could import it like this. We can import, qt, what was it, crypter window. We could import it like this, like this, and also we could somehow delete this part and import it from Windows, import crypter window. In order to do this, we have to initialize it. We have to import it in our Windows init.py file. We have to create a file here, name it like this with 2 underscores before and after init, and try importing it like this from crypter. Note that this crypter.py, we are calling this one next to this init.py. From crypter import what was it, crypter window. Now we can go to our main file and actually import it from the Windows directly, and we don't need to point to this crypter.py anymore because it's imported in the package. This crypter window is imported inside the package. So now that we have our crypter window, we can go here and say, if underline name of this is equal to main, which means that this module is being run, it's being executed directly, it's not being imported anywhere, that we are actually running this main.py directly. Next we create an object named app, and from qt widgets.qt application Q application, we actually make an object from it and pass the arguments sys.argv, which are actually the arguments sent to the module while actually running it inside the terminal. We pass them here. I want to do an optional step here. This is optional. You can set the style to Fusion. I like this style. Then we have to make an object of our window and call app.execute. Now we can call our, what is it? Call it again. No module name crypter. Where? From crypter.py. Here. Where is it? Inside our init.py from crypter. We have to name it relatively. We have to import them relatively because it's inside the package, and it searches for the crypter.py from the root folder here, and it cannot find it. But when we actually add a dot here, we ask it to look for descriptor.py inside where it is, which means here, here. Yeah, this is the package it lives in. So when we press dot, it looks for it inside of this package, his own package, and it can find the crypto.py here. So now let's run it again. Okay, another beautiful error. This time UI.low UI here. Okay, let's see. Errors are part of programming, so don't panic and try to solve them. It's asking me, it's saying me that this is not correct. Let's see what it is. Okay, template address is wrong. Assets, templates, we have any misspelling. Assets, what did I write, man? Okay, this guy, asset, this S is not okay. Assets, templates is okay. Templates, yeah, I think it's okay. Let's try again. Another error is still that error. Yep, it's still that one. Module object is not callable. What do you mean, man? I expect a more descriptive error message. I'm so sorry guys, this load UI is in camel case, not in a snake case. We have to write it like this. I did it wrong, so let's try again and see if everything is okay. Yeah, it was okay, but it finished, I think. Yeah, it didn't stay. Let's see why. Let's store this inside of a variable. Test it again. Yeah, I don't know why do we have this bad design here. The whole error was because of a variable. I'm not sure what is using this window, because it's not being passed here, and it was the whole reason of the error. What was the word? I forgot the word, but it's so mysterious. Okay, guys, I don't like this. Yeah, I want a margin here. Let's create a margin. Let's go to our designer and click on our window. Not sure if we have to do it on window or vertical layout. Let's test window. I want to see if we have any margin. We don't have margin here. What about vertical? Yeah, we got some margins here. I selected our vertical layout and search for margin. We got left margin. I want to have a 12. Not sure if this is a proper number or it's too much. Let's check it. I save it. Could not open the file being used. What do you mean, man? Would you like to return the system cannot find the path specified? Select new file. Okay, go to desktop, my package, assets, templates, and descriptor.ui file. Yes, replace it. Let's run it again and see if we have a beautiful margin. Yep, I think it's okay. This 12 pixels module margin. Okay, next we want to select our file when we click on this label. Let's go to our let's go to our window and create a signal here. Select what is select? Self dot. What was the name of our label? Select label. Okay, self dot select label dot mouse press event equal to a function. I want to name it self dot select file, and we have to create this private select file. The reason I change it to a private method is because this method is not supposed to be imported in anywhere else, not supposed to be used outside of this scripter window class. You could delete these two underlines here and make it a public method, but I don't think that is a good idea. Okay, name it select file, and here it is. We have to open our file select window, file select dialog. I create an object named file dialog, and from qt widgets dot q file dialog I create an instance. Then we get the file path and something else I don't care about. I'm actually unpacking it into two variables. It actually, the thing we are going to write at the right side of this equal sign is going to return a tuple, which I want to unpack it into two variables, name file path, and I don't know what this one is going to be, but whatever it is I don't care about. Next we call our file dialog dot get open file name. I'll pass this guy self and a message. For example, select a file or select any file. Not bad. Then if file selected file path, actually we got a file path. If it's a true C, not a false C. First of all, let's see if we can change this line edits content into the file path. Try to do it self dot path line edit, which I named it path line edit dot set text to these actually file paths. Let's see if it works. Go to our main and run it. We open, oops, doesn't open, why not? Yeah guys, I think I misspelling it here. I think mouse got an E at the end. Let's see, I think it's the reason we couldn't open the file dialog. Okay, select file takes one positional argument, but two were given. At least we're seeing the error. Select file, get self. Yeah, it gets two objects. Okay, I'll pass the extra ones at args, because I don't need them. Let's run the main again. Come on. Yeah. Okay. Now we can select a file. I want to select this main.py. I want to select itself. Yeah, we see that the address will be added to our line edit. Beautiful. Everything is working properly. Everything is okay. Next, let's enable and disable these two buttons. I want them to be enabled, clickable, whenever this line edit is filled. Otherwise, I want them to be actually disabled. I don't want them to be clickable. For that, I close this and go to our scripter window. I make another signal named self dot, what was the name of that line edit? Path line edit. Path line edit dot, I have to call it text change. I think it was text change. Text change dot connect. Yep. Now we pass the name of the method we're just going to create. I'll name it path changed. Then close this. And name def, pass full on, self, and here. It actually passes the text as well. Then we want self dot encrypt button dot set enabled to the boolean of this guy, this text. I mean, if it's empty, I want it, this boolean will be false, and the set enable will disable this encrypt button, and I want the same for decrypt button. Decrypt button. Let's test it. Go here. Open it. These guys should be enabled, disabled. Why aren't they? So because of that, you know, the problem is that these two buttons were enabled at the time we opened the window. In order to prevent this from happening, we have to decrypt, we have to disable them from the designer. We call enable, search for enable, and actually disable these two, Control plus S, in order to save it. And now let's run it again. These two are disabled at the beginning when we select a file. These two are still and enable. Creator window has no attribute encrypt button. Okay, I think name is wrong. Encrypt button. Was that a misspell again? Cryptor self dot encrypt button. What was it? And oh shit, we forgot N. Okay, encrypt button, decrypt button. I think this guy is wrong. Right. Test it again. Buttons are disabled. Let's select, and now they are enabled because this is filled with something. Okay, this is okay. Now that the file is selected after filling the line edit, I want to fill the label itself and load the file. If it's an image, I want to load the image itself. Otherwise, I want to load an icon for it. For that, I call another method which I'm going to create again, and I name it set label icon. I call it, and I want to pass it this file path. Let's create this guy again. File path, and here we want the file's icon path. Icon path, we get it from a function name get file icon path. As the name this name describes, this function is going to return either an icon path or actually the file's itself path if it's an image. The file's path and will be stored in this file icon path. We will actually implement this function after creating this function. This function should actually get this file path as well in order to know what the type of this actual file is. Next, we create a self.pixmap attribute and make it equal to qtg.qpixmap, if it's here, yeah, pixmap of the address we get from our function. This qtg has been imported here. It's actually the qtg UI. Next we want the size of our label. It's the select label, and we write select label size and then make it equal to our self dot select label dot size method, which will return the size of our select label. We want the icon to be resized to the size of our label. Then we write our pixmap to be equal to itself, self.pixmap.scaled. We actually scale it to the select label size, and then qt core dot qt dot aspect ratio mode dot keep aspect ratio, and another one qt core dot qt dot transformation, I think transformation mode, yeah, transformation mode dot smooth transformation. Yes, and let's format this document. I'm also yeah, I want the black formatter, yeah, in order to structure my code. Then we have to set this pixmap on our actually label. We say self dot what was the name, select label dot set pixmap, and we call this self.pixmap. The next thing we have to do is to implement this get file icon path in order to get the correct path of the file. I want to implement it in my utils. I want to have a package here, name it helpers. Yep. Here I want to create a file name get file icon path.py, and a folder with this name, and it gets file path. For now let's leave it empty. We need an init.py. Make sure to have double underscores before and after init. Here we say from this guy import this guy. Don't forget to put a dot here, which actually point to the current directory that this init.py exists. That means this helper function folder, which point to this get file icon path. This whole guy points to this module. Okay, then inside this function, actually let me note that this function is going to return a str, a string, and this file path is also str. These two guys are optional, you can totally ignore them. These are just some annotations. Here we check if the file is locked. If is locked, we have to pass file path here, and if it's locked we have to return lock icon path. Because these two are not defined yet, we comment this code. I don't want to delete it because I might forget implementing it. So let me actually comment it. We will implement it soon after these other guys. I want to use the match case structure. We get file extension. This is the function we have to implement soon, and if the case is JPEG, or JPEG or PNG, we return the file path itself, because we want to show the image itself if the user selects an image. If, for example, it's a PDF file, we return PDF icon path. If it's MP4 and MKV or AVI or any other video format you might know, we return actually video icon path. These PDF icon path, video icon path, or anything else we are going to write should be implemented. Just wait. If any other file type happens, we have to return default icon path. Yep. Now we have to implement this get file extension, PDF icon path, video icon path, and default icon path. These three are easier, so let's start from these. We go to our assets and create a folder here, name it icons. Okay, before actually recording this video, I was practicing on the similar project, and I had saved some icons here before I started to record this video. I want to copy these three and paste them here. Doesn't get paste. Hello, Mr. Microsoft. You don't let me paste them here. Come on. Wow, paste button. Okay. What about if I drag them? Come on, Microsoft, do something about these. Okay, now these three can be implemented. Let's go in our utils constant.py. We want to go here. Now let's declare the instance here. One of them is the PDF icon path, which equals to OS assets underline path equal to assets, and icons path equal to os.path.join assets path to icons. Let me smallize it a little bit. And now our PDF icon path should be os.path.join our icons path appended to, what's the name of this, pdf.png. Okay, pdf.png. PDF icon path, image icon path. Oh, we didn't have image. We can go with video icon path video1.png, if I'm not wrong. Yeah, video1.png, default icon path, this turns into default.png, default.png. Then is there anything else? This add button, we didn't use it, so I forgot to delete it from there. We don't need it here. Okay, lock.png, lock icon path, and then lock.png. And this assets path will be replaced here. Don't need that there. Well, I think we have these. We have all of these we want. We can go here and import them all. We can go to from utils.constants, import PDF icon path, video. Come on. Is that in there? It's not there. We don't have video icon path. I deleted it. Okay. Video icon path, video1.png. Okay. Then here, video icon path and the default icon path, and the lock icon path will be returned here, but we don't want to implement it now. Now let's go and get file extension from the file path. This needs to be implemented in our helpers function. We create a module, name it get file extensions.py, and this function here, we don't need this guy here. It gets file path, which is absolutely an str, and it will return an str. We can return the file path, split it with this dot, and return the last, the last item of that cell, of that list. This will return the extension. You could also check with the MIME type as well, but I just want to check it with the extension. That will be a better practice if you do it, but I think it's enough for this application. Someday we might get back and change this get file extension and use some third-party libraries, but for now I think this implementation fits our needs. Let's get here and get file extension. I copy the name and go to init.py and change them here. So now in my get file icon path, this guy should be imported. We can go from utils.helpers, import this get file extensions, and now this guy is working properly. Let's test it. Let's see if it works. We go to our main.py. Actually, we run it. Let's try to select an image. I go to my pictures, wallpapers, and select this تخت جمشید. It doesn't work. What's the problem? File icon path, get file name, get file is not defined. Did you mean file icon path? Get file icon path is not defined here. Okay, let me see. Get file icon path not defined here. Yeah, you're right, it's not defined here. From utils.helpers import get file icon path. Let's test it again. Go to domain.py and try to run it. Let's test it. Go to our pictures. Select تخت جمشید. Doesn't work again. Is not callable. Module is not callable. Get file extension is not callable. Why not? Where do you mean exactly? This get file extension is not callable. We didn't import it in our init.py. We did it. Get file extension. Get file extension. What's happening here? And get file icon path. Because these two guys are at the same package, helpers, it doesn't actually it doesn't import it from this init.py. So we have to call this get file extension path. We have to import it from the module. That's because these two are at the same package. The reason we import it here is because we don't want to write the package's name, but because these two are at the same package level, we have to write it. That only works if we want to import it from outside the helpers package. So here we have to write it, and that's something we have to live with. Okay, let's import it again. Let's see what's the other error. Wallpaper تخت جمشید. Oops, we don't have any error. This is working. I think it's okay for now. We can select as many image, or let's select another file type. Let's go to our desktop here. Let's select Python file type. The default image is being shown, the default icon, because we choose actually a file, .py file, which goes here. Get file extension file goes here and returns the default icon path. Okay, seems that our application is working correctly. By the way, guys, the images I copied here are available at my GitHub repository. I will provide you with the link in the description. You can check it out. We could also write this like this. We could get out this return here, and that would be a correct implementation, but for now let's forget about it. You could experiment that as well. Okay guys, now let's focus on the encrypt and decrypt. When did I import this? Okay, let's get back to our designer and make a new window, create it. As always, remove this menu bar, smallize it a little bit, calm down, and okay. I want a layout, vertical layout. Okay, right click here, layout in grid, add to line edits, a push button. I select first line edit, come here and search for the placeholder, set it to password. The next one, repeat the password. Then let's change it to encrypt. Smallize it a little bit, see what we got. Not bad, it's okay. Let's add a little bit of margin because it doesn't have any margin. I actually select the vertical layout and search for the margin. I add 8 pixels of margin as well, and let's create another template as well. Can I copy it? Okay, we can't copy it. Can't copy main window. No, we can't. Okay, let's stay safe and create a new one. Create, bring it here, repeat the same process, smallize it. We need a horizontal, a vertical layout, layouting grid. We add a line edit and a push button. This is for the time we want to decrypt our file. We have to set the we have to actually provide the password, enter the password. I select the line edit, search here for the placeholder text and write password. And here decrypt. Well, I think it's okay. Let's change the names. This is password, line edit. This is password, repeat, line edit, and this is the encrypt button. This guy is also a password, line edit, and this guy is the decrypt button. Well, I think it's okay. Encrypt button, make sure we don't have any misspelling. Password, line edit, password, line edit, and decrypt button. Okay, let's save them. First one, I select the first one, come here, save as, and I choose name of encrypt. I save it. The next one, file, save as, I choose name of decrypt. Save it. Let's get back to our code. Let's go to our constants.py. By the way, I press let me open cast mode for you. I press Ctrl P and search for constants.py. Here I want to add a template file. I make some copies. Then template file is okay. Just 2 copies are enough. I delete this guy. Let's write encrypt address and oh, what am I doing? I'm so sorry. Encrypt template address. and this guy is going to be decrypt template address. As usual, we have a misspelling here. Encrypt template address is okay. Template address, that will be changed into encrypt.ui, and this guy is going to be changed into decrypt.ui. Well, I think these two are okay. Then let's go to our Windows package and create a new window, call it encrypt.py. I want to borrow some code from this crypter file. Then want to change the name of this guy into encrypt window. We need to change these two into encrypt template address. If we want to forget about these two and these guys as well. Let's test it. Let's see if we can open this encrypt window from our crypt window by clicking that button. We turn back into our crypter window. Here we need to have a click listener for this encrypt button. Name is encrypt button, so we come here and write self encrypt button dot clicked dot connect self dot open, or let's name it encrypt. I think it's enough. Let's implement this encrypt folder, this encrypt function. Close it. Come here, close this guy as well, and this encrypt self. Yep. We can come back to init.py and declare an attribute here, self.filepath, and the initial value of this guy is none. And now in our encrypt method we can check if this guy, what happened, if this guy is none, return, don't do anything. But if this guy has value, where should the value come from? This guy's value should come from select file. When the file is selected and the label icon is set, we have to set this file's name it, and give it the file path. And now the self.filepath has value and it's no longer none. Then let me bring it up. Then we actually try to instantiate our encrypt window. Encrypt window, make it equal to the encrypt. I believe we didn't import it here. So from here we go from Windows, import. Okay, we didn't add it to init.py here. Encrypt, add encrypt Windows, same thing for decrypt and decrypt decrypt window. Encrypt window. Oh, that's not implemented yet. Oh, I thought I did it. Okay, let's comment it for future. Then import the encrypt window here from Windows, but there's another problem. These two are the same package, so this method we used is not working. So we have to say from Windows dot encrypt import encrypt window. So this is not useful. Yeah, these two are not useful, so I want to delete them. Encrypt.py. Sorry, cryptor.py. Here we can now instantiate it. Encrypt window. We can, let me close this guy. I think this cast mode is actually bothering you guys. I don't know. Let me turn it off. Okay, it's not working anymore. For now, we have to add context to this. I want to pass it a dictionary which has the key of file path and the value of self dot file path. So we are sure here that this self dot file path is not none, because if it was, it would return here. And then we call the show method of our encrypt window. That will make that encrypt window to open. Let's test it. We go to our main.py. I pressed Control P to open up that search window. That search actually lined it. And now, okay, let's select the file and press encrypt. Okay, nothing worked. Context is an unknown keyword argument. Okay, that makes sense. We go to the encrypt window here. Why does that? It doesn't make sense. We are getting it from this with these keyword arguments. Of course I need it, but it shouldn't raise any error. Let me test again. Yeah, that was weird. Let me check it a little bit. Where was it? In encrypt. That's weird, guys. That's because yeah, I got it. That's because inside this encrypt window we're passing the actually keyword args to the parent, and the parent doesn't expect this context keyword argument. And when we separate it from the keyword arguments, we are no longer passing it to the parent, so that doesn't raise any error. Okay. Now, in order to make sure we can print the context and see if we can print the file address here. Let's see if it works. Control P, search for the main, and run it. Okay, select a file, select encrypt. You see that this is successfully passed to our actually encrypt window. Here in the encrypt window we have to encrypt the file. Actually, we type self.encrypt button dot clicked dot connect self dot underline underline encrypt. We make a private window and name it encrypt. Then we have to extract the file path we get from the context dictionary here. We write self dot file path equals to context. Okay, we got two options here. We can get the key like this, file path, which will raise error, key error, if the file path key is not provided in the context dictionary. Or we could go with this as well, get, which will return none if the file path is not presented in the context dictionary. You could go with both of these two options, but I think I want to make it mandatory for the user to actually provide the context with the file path key. So I want to raise error if that's not provided. I go with this option. If that's not in your choices, you don't like it, you can go with the options I just showed you with .get method. So now we have to implement this encrypt method. We come here, def encrypt self, and let's check. First thing we have to check is that if these two passwords user typed are okay, if they're equal. So now for that we check. For that I like to make another method. Name it passwords are equal, and self, and just self, I think is enough. We return if the self dot password line edits is equal to get text, get text is equal to self dot repeat, what was the name, password repeat line edit. Okay, password repeat line edit dot get text. You want to return this, let's format it. Okay, nothing happened. Okay, now we could check here if self dot passwords are equal. I would like to rename it and write are passwords equal in order to show that this guy is going to return a boolean object. So now if the password is not equal, we have to self dot show a message box with the title error and the text of passwords do not match. But since this show message, let me, I was right, let's name it message box. This show message box is not implemented, I want to comment it out. Then actually if they're not equal, we don't want to continue this function, this method actually. We return it in order to finish this encrypt method. But here means that the password is okay. Okay, then we want to get the key, which is actually the password that user typed. So we have to get the password first, and that's self dot password line edit, and that will not have any open and close parentheses, but this guy has a text method, but we did it wrong in our equal password. We have to write text, not get text. Yeah, we have to change this. Okay, let's get back, get the key. In order to get the key, guys, we have to turn it into bytes array. So Python has a method named encode which will do the trick for us, but there is a problem. The library we're going to use in order to encrypt the file is called fernet. Fernet needs the key to be a 32-bit key, but we can't expect the user to type a 32-bit key. So we have to somehow create a helper function here in order to resize the password that user types and get the exact 32-bit key. For example, if the password is too long, we have to shorten it, we have to crop it. If the password is too short, we have to append something to it in order to get the 32-bit key. So that's the duty of the next function we are going to actually introduce. That's called fit key, which fits the key. This fit key function is going to be live in the helpers module and needs to be implemented in utils. Helpers also need to be implemented here, actually need to be imported here. Fit key, and let's create the module, name it fitkey.py, and the fit key, it gets a key which is an str, and it's going to return bytes. Yeah, has to return bytes. So here, if the length of this key is not equal to 32, we have to get the remaining length, and that's 32 minus the length of the key. If it's positive, if the remaining length is positive, means that this key's length is less than 32. So we have to append something constant to it, something that we know. That will be a key, the augmented assignment operator here, the bytes of, for example, a string A. We turn it into bytes, and then let me okay, we multiply it into the remaining length. We actually make a bytes array of string A with the remaining length we calculated here and append it to the key, to the end of the key, and that will be the password that user types and some A's at the end. But what if it's not? What if it's not like that? We make the key equal to the key from the beginning into the character at index 32. Okay, when this is done, we have to return the key. Return the key. But the key cannot be just returned like this. We have to import the base 64 and return base 64 of URL base 64. I think encode. Yes, encode, and that will make the key in the proper format. Now this feed key can be easily used in our library in the encrypt windows, which we used here, and we can get the key. But in order to make sure, guys, I want to print this. Print the key, and actually the type of this key. Let's see what it is. Go to the main. I hope we don't get error. Okay, let's choose this main.py, encrypt. I enter 1 to 3 and then 1 to 3 again, encrypt. Okay, class is bytes, and this is what we get. Although I used the base, I used 1 to 3, but this is what base 64 format of that guy. What will happen if we didn't write that base 64? Let's see. Well, if we actually return this guy, let's see. Close that and close it. Test it again. Main encrypt 1 to 3, 1 to 3, and encrypt. See, the password 1 to 3 is here, and some A's appended to it, making 32 bits. And I think this is well done here. And let's go to the feed key and delete it. Okay, in the encrypt window, we don't need these print, and we have to open our file with open self.file path. As file, and make the data equal to file.read. Can we be concerned about this file path to be null? Yeah, it can be sent null here. Yeah, we have to check for that as well. If self.file path is none, forget about it for now, but we need to raise an error, actually a message box dialog, and say that no file is selected. Okay guys, next we have to make an object of the Fernet class and pass it the key we just got, and make the encrypted data by calling fernet.encrypt and passing it the data, actually the clear data. Here the Fernet should be actually imported. We come down here, we write from cryptography, I think, cryptography dot fernet import fernet. I'm not sure if this fernet is coming with Python itself. Let's test it. I go to the Python shell and write the same thing I wrote, cryptography dot fernet import fernet. Yeah, no module name cryptography. I think we have to install it. Let me search for it. Python Fairnet. No PyPI. It's weird. Fairnet PyPI. Yeah, this cryptography. How many? Yeah, from yeah, exactly. I'll copy it, get back to my shell and paste it here. Let's install it. Okay, it's installed. And let me test it. I get this guy, come here and write. Let's go and do it in the VS Code. Close this shell, open a new shell, and go to Python and paste it. No error. No error. Yeah, that's right. Okay, it's installed, and now that we have our encrypted data, we have to know where do we want to save this encrypted data. So we make a variable named save2 and call a function named self.where to save. Yeah, this function pops up a file dialog, actually a directory dialog for the user to select a directory or even a file. Select a file in order to be replaced. Okay, let's implement this where to save. Where to save self. It gets a folder, actually a path. And we unpack this second one is an underline because we don't need it. We say qt core.q file dialog. It was not in q file dialog, qt core, qt widgets.q file dialog. Yeah, dot get save file name, pass it to self, and the message where to save. And then return the path. It can also be none. Okay, this save2 can also be none. So if save2 is none, we don't want to do anything because the user canceled the process at the middle, and I don't see any necessity to show him any message box or error or anything. Just we actually stop the function. But if that's not none, if the user has actually select a directory, a path, we have to write this encrypted data into the save2 path. By the way, this path cannot be a directory's path. It has to be a file path because we are going to write to it. So let me change the name into file path. This is more descriptive. Okay, here we have to write to that file. We get here, we open the file self dot, okay, not self dot, we open the save2 with the switch. We want to write it in bytes format as file, and we write file dot write the encrypted data. Next we have to actually open the file path. or file directory. We have to get the actually file address. We write file path equal to os.path.dir name of that save2 we just got from user, and then we have to start the file with os.start the file path. Next we have to close the window. We have to close the window, and we'll call self.close method. Seems okay to me. Let's test it. Select this main.py, encrypt 1 to 3, 1 to 3, encrypt. Doesn't work. Why not? Data must be bytes. Okay, but why is it not bytes? Get no fairnet.encrypt clear data. This is not bytes. Clear data is a file read. We have to say it that is read it in bytes. Yeah, I think this was the problem. Let's test. Main.py encrypt 1 to 3, 1 to 3, encrypt main. Yeah, do you want to replace it? No, don't want to replace it. Go to desktop. Let's create one for it to replace. Locked. Save it. Saved and open the folder for us. Actually open the desktop, and the locked is saved here. We can open it with notepad to see the contents. It has to be some nonsense content. Okay, that seems okay. Next thing we have to create is, what should we create? Let's create these message box. So I copy the name, I actually uncomment these, I delete these ellipses and add a return here, copy the name, and I come down here and def self and show message box. Okay, for this we have to actually make a message box from qt widgets dot q message box. I think q message box, we pass it to self, we come down and message box dot set text. I think, yeah, I want to get it from here, title and text. We add actually text here and set title. We don't have set title, really. Set window title and set window text. No, set text and set window title. Okay, this guy should also be title. Next we can set an icon for it, call message box dot set icon, and we have to use qt widgets dot q message box dot icon dot, for example, critical. We could make this icon dynamic like title and text, but for now I just want to ignore it. I put it on your own, you can do it if you want. Then we call messagebox.exec in order to execute it. And now I expect it, if the passwords are not equal, I expect it to show me this message box. Let's test it. Let's go for the main, encrypt, 1 to 3, 1 to 4. I want to see the message box. Yeah, passwords do not match. That's good. And actually our encrypt is working properly. One thing is bothering me is that we have the passwords in the clear text. I want it to be in a password mode. I don't want to see the password while we are typing it. What was the property for this? Password text secret has to be in Q line edit. Put mask, no. Drag enable echo mode. This echo mode should be turned into password for this guy as well, and also this guy is echo mode. Turn it to password, and we have to save these two, this one and this one. Let's test it. Go to main.py, run it. Inside in here, encrypt. Yep, we see that the password is no longer this guy is visible. Why didn't we change it? This guy is normal. Password. Save it. What about this guy? This is password. Okay, let me test it again. Encrypt. Okay, this guy is in password mode. Okay, that's right. Now I think our encrypt is working properly and we don't need to change it anymore. Guys, this encrypt function, this encrypt method is a little bit long. I want to shorten it a little bit. I want to extract these two into a function named getKey. And this getKey function self.getKey. This getKey function def getKey self will return it. Return this guy. Here's the password. What did I do? Okay, key equal to self dot get key, and this is the password. I copied these two lines and I extracted them into a function get key and get the key from here. This step is optional, guys. You can ignore it, but I want to make it a little bit shorter. I do the same thing for this. Encrypted data. I want to get let's cut them. Encrypted data and self dot down the line get encrypted data. Get encrypted data, and this needs to be implemented. Def gets encrypted data self and return it. Where is the clear data? Okay, this guy needs the clear data. We can pass it here. Or we could make another function named get clear data and copy these two lines there, but I don't want to do a lot of optimizations. Where is this key being used? Come on. This has to be used inside to get encrypted data, so we can cut it from here, bring it here. We have to get the key, create the fairnet object, and return this clear data. Pass it to get encrypted data, so we get it here, and return the encrypted format of that guy. We get the encrypted data, where to save it. If it's not presented, we return. We open and write into where we have to write. We open the file directory. I want to actually cut these and make a helper function named open directory and pass it this save to. Import it into helpers from helpers. Seems that this get file icon path is not being used, so I replace it. Open directory. Make sure not to copy init. Not inside of Windows, in utils, helpers, init, from that get or open file directory, import open file directory. Create a module here. We make a function of def open file directory self directory. This is a string and returns none. This step was optional. You could skip the annotation, and let's do this guy. Let's do this. File path is os file path dot directory. The OS should be imported, and this should be actually open file directory, and get back to encrypt. Open file directory, make sure to replace the name here because we changed the name. Get back, open file directory. I think our encrypt function is more actually it's shorter now. It's better. We could make another function named get clear data in order to make this also a little shorter, or write, for example, like write encrypted data, make this one shorter. I put it on your own if you want to, but for now I like to actually ignore it. Okay, we don't need to do anything more on our encrypt window. Let's go and work on our decrypt window. I create a file here named decrypt.py, come to our encrypt, copy all here, come to the top and replace it, decrypt window. We load the decrypt template address, we show the file, encrypt button is actually decrypt button, click that connect, we have to rename it to underline decrypt. We need the file path, we get it from the context. Yeah, passwords do not need to be equal because we just have one password. The key needs to be actually retrieved, and this is what we need. Get encrypted data is actually should be get decrypted data, so we have to call decrypt here and get decrypted. Get decrypted data inside the decrypt folder. If file decrypt method, if file is none, no file is selected, has to be shown. If passwords do not match, we don't need this one. We have to open file path, this file path. Yep, we need to read the content, but it's no longer a clear data, it's actually encrypted data. Get this is get decrypted data, and yeah, we could write, yeah, because we write that one clear data, let's write this one clear data. Get cleared data, and this one is cleared data. Where to save it, we got the function, we got actually where we want to save it. Save to, no, not there, return it. We need to write cleared data, we have to open the file directory, we need to close the directory. But guys, by the way, where to save method is being actually implemented twice, once in the decrypted module and again inside the encrypted module with the same implementation. We have two options here. We can actually make another window class and inherit these two from the that's a guy, or we can make it a helper function. Both of these are, I think, good practices, but I think it's a better practice to make window related helper functions inside of a parent window.py. Let's do this. I think it's a better practice. I copy all of these encrypted data, encrypted window file, and paste it here, name it window. I don't need to open anything or load anything. It doesn't have any of these, no context, just a normal main window. None of these are needed, none of these are needed. Where to save is needed. Show message box, yeah, I think this guy is also needed because we need it. This is actually frequently needed. So now we go to our, for example, decrypt or encrypt, both of them. Now that we are working on decrypt, let's do this. We delete this where to save method, we don't need it. We have to import our window. We say from Windows import window. I think we forgot to import it. Oh, because both of these are inside the Windows package, we can't do that. So we say from windows.window import window, and then we try inheriting this from this guy window, because this window is being inherited, derived from this Qt widget. We no longer need to inherit that guy here. So now we have actually the where to save method. We don't need to implement it anywhere else. And inside the encrypt folder as well, we can delete this where to save and instead try to inherit it from windows.window import window. We could actually delete this, but I don't like relative imports. I want to import it absolutely. Okay. Now I think it's a better implementation. We used less code and I think it's better. Show message box is also not needed because we have it in our parent. So we delete it. We don't need to implement it twice into actually window. We could do it with get key, but you know guys, this get key only works on decrypt and encrypt module window, because password line edit is not presented in all of the windows. For now it will work, but for future, if we want to inherit this window in other windows, that will raise error, because you know, these two methods we implemented here are not dependent on the crypt window or encrypt window, but the get key only works on these two, and I don't like to, you know, import it or to implement it inside the window, although that it makes my code a little more cleaner, a little more clean. More clean or cleaner? I think it has to be cleaner. Okay, forget about it. Okay, inside the decrypt module, we no longer need anything else. We write the clear data, we open file directory, and we close. You know guys, I don't know if I want to keep this open file directory inside my helper function or implement it in the window class. I think it's more of a window related method, not separated from window. So I like to somehow delete it from here. You can keep it here, you can skip this step, but I would like to go and also open file directory. We have to delete it from here as well, but I want to implement it in my parent window because I think it's a more window related method. Def open file window, it gets a directory and opens that. Now here we have to call self.open file directory. Yeah, let's make it private and make sure to rename it in the window as well. Self.open file directory, and also in the decrypt self.open file directory. This is optional guys, you could keep it in the helpers function. I would like to implement it in my parent window class, so this is no longer importable, and also in the encrypt module. Well, I think our decrypt should also work. Do we have the signal for it? No. no, not here, sorry, in the decrypt. Yeah, we have the signal for it. I think it has to work. We don't pass the context. We have to go to our crypt. Where is it? Control P, crypt window, and you have to have something like encrypt. I copy it, I paste it, I name it decrypt. If path is none, we return, and then decrypt window, and name it decrypt window, and then we import it here. Decrypt window. It's wrong. Decrypt window. We can't import it here. Sorry. From Windows dot decrypt import decrypt window. That's right. Now this has to be possible. Now let's make the button signal decrypt, and yep, that guy works. Let's see. Let's go to our main.py and run it. Oops, what is that? We are importing it somewhere. utils.helpers in my window.py line 10. Okay, why? Where is it? Window.py line 10. We don't need it anymore. Let's get rid of these not used dim imports. Yeah, and also in the encrypt, don't need this Qt core, Qt GUI, this Qt widget, none of these two. In the window, the decrypt, many more, Qt GUI, Qt core, Qt widget, none of these two. And okay, I think it's better. Let's go to the main again and run it. It works. Let's open an image. Go to this image of Ghal Erud Khan. Encrypt. What's happening? Oops. Decrypt window has no attribute. Oh, I have a misspell here. Yeah, of course I mean this. Where is it? Line 16, okay. Decrypt. Button click that connect, yeah. Let's do it again. And select an image. This time تحت جمشید. Encrypt. Why does it open these two? Let's check it. Inside the encrypt folder, we have a self.encrypt button. I click event, it opens. Oops. First of all, we are facing a misspell here, but that's not the cause of our problem. Second of all, encrypt button that clicked, open encrypt, open get encrypted data, open file directory. Oops, what is this? Come on, get rid of these. But these were not also the reason of our problem. They don't live anywhere else, huh? Or decrypt. No. I think the cause of the problem should be in the crypter window. Let's go there. Crypter window. Yes, these two are the same name. This guy should be decrypt button. Decrypt button. Come on. Decrypt button. Yeah. Let's go to the main and run it again. Select a random image and encrypt. Num-block is off. 1 to 3. 1 to 3 and press encrypt. Okay, error. What's the problem? Attribute error. Encrypt window object has no attribute. Where to save? Did you mean? What's happening? That's because, yeah, I made a mistake. That's because these guys are private methods, and private methods do not get inherited. So we have to delete the underlines, and then inside encrypt and decrypt we have to Control Shift F and try to replace it with where to save everywhere. Replace all. Yeah, replace all. And also this had to be done in the decrypt window. Why is not changed here? What are you doing, Microsoft? What are you doing? Okay. Not just these. Also show message box and open file directory. Let's search these two as well. Show message box here. Let's find these and replace them with these. And replace them everywhere. And also open file directory. Find it and replace it with this. Replace. Yeah, now it has to be correct. Let's test it again. Open. Select an image, encrypt. 1 to 3, 1 to 3, encrypt. Opens. Where do we want to save it? We want to save it on our desktop. Replace it with this image. No, not this image. We want to replace it. We don't want to replace it. We want to create a new file. Locked image. Name it .jpeg as well. And save it. Yep, locked image is saved. If we run it, we can see it. Okay, does the decrypt also work? We have to see. We click to select another file. We select our locked image. Pixmap is null, so it's not showing anything. We forgot to implement that. Yeah, we commented that code and we will get back to it and create it. But for now, let's see if decrypt works. We press decrypt, it asks for the password. Let's see if it returns error if the password is wrong. No, it doesn't return error. Invalid token. We have to catch that exception. But let's see if that works, if it's enter a correct password. We go here, we select our locked image, we press decrypt, password was 1 to 3. Does it work? Decrypt works. Replace it on the locked image, press save. Yes, I do like to replace it. Yep, it works. Locked image is no longer locked image. And we can see Okay, let's let's actually first, what was the problems? First, let's get rid of this and show a lock image if a locked file is selected. Let's go into one of our helpers functions named getFileIconPath. We commented the code here. I uncommented, and lock icon path should be imported. I think we did import it. We did declare it here. Yeah, this lock image. Let me close. Okay, we close those we don't need. Okay, let's implement this is locked method from utils.helpers.isLocked import is locked. We are going to implement isLocked.py def is locked. Okay, how should we know if a content is locked? The algorithm we are going to use is to append the file's content with a constant string and check for that string whenever we load a file. If that strings exist at the end of that file, it means it was a locked file. We just locked it. And if not, it means that this file is not locked. For that, we go to our constants.py and create a variable constant here named signature. I name it, I actually make it like this, mj lock. I think it's cool. And this signature, if this signature, you can make any other signature you like, no matter what, but try to make it unique, not something that is frequently used. This signature should exist at the end of our file. So inside our encrypt window, when we encrypt a file, we get encrypted data inside this method. We shouldn't just encrypt this. We have to add the signature dot encode in order to have the bytes, but this signature needs to be imported from constants, import the signature. Yeah, that adds the signature, the bytes format of our signature into the clear data. Because our clear data, I think it has to be in, yeah, it's in bytes format, so we have to make it bytes. And also inside our decrypt, we get clear data. I think we have to modify this one. We get the key, we make a fernet object, we decrypt it. But the problem is that, first of all, this is not a clear data. This is an encrypted data. Okay, encrypted data. Let me see if we, yeah, this is the encrypted data. The encrypted data contains our signature. When we decrypt it, okay, set clear data is a bytes array. So when we decrypt it, let me check it here. Decrypted data. We have to delete the signature from it. We have to say if decrypted data that ends with signature that's encode. Let's import it here from constants, import signature. If that guy exists, decrypt it. I think we don't need it. We don't need it. We could return it like what we had. And here we need to replace our signature. We have to import it here. I've imported it. And here we have to replace our signature. Make sure to import it here and encode it. Encode it and replace it with an empty byte. I think it makes sense. If this signature does not exist, so this replace will not do anything. And if it exists, it actually replaces it with an empty bytes. So now in our isLocked method, we can check to see if our signature exists. If the signature exists there, it means that the password is locked. If not, the file is locked. If not, it means it's not locked. By the way, guys, in the decrypt window, we replace the encrypted data with the signature, but we didn't actually. We replace the decrypted data with signature. It means that the signature should be appended to decrypted data, should not be decrypted. So we need our signature in clear text. That means that we did it wrong in our encrypt window. We shouldn't encrypt our signature here. We should do it something like this, I think. Yeah, this makes sense. We have to first encrypt the data and append the clear bytes array of our signature, not encrypted type of it. And that makes it possible to be replaced here. Replaced with the decrypted file, with decrypted content. And also it's possible to check for it in our isLocked method. So now, here I try to import our signature from utils.constants port signature. Now we see how this is locked being used. It gets the file path. Okay, so it needs to open it. With open file path. With open file path, that self was not needed. As file, you can open it in a clear text. We don't need to add this switch here. This is the default switch. So we return if this signature is in the file dot read, or no, not in, if the file dot read dot ends with signature. Yeah, if it ends with the signature, it returns true. If not, it returns false. And here, if the file is locked, we return icon path. Let's test it. I think it has to work. Let's go to our main.py, run it. Previous locked files are not useful for us, so we try to have a new one. We select an image. Oops, got error. What's the problem here? Guys, let's check if it works in the bytes mode. Make it encode in order to make it into bytes array and read it in bytes mode. Let's test it. Yeah, that makes sense if it works, because the text does not exist in an image. Open file must have exactly one of create, read, write, append mode, and at most 1+. Oops, I thought it's the default switch. Okay. And guys, we actually specify the total switch. We want to read it in the bytes mode. Okay, it opened, and inside the picture, let's choose a picture. It works. Yep. And now let's encrypt it. Let's encrypt it. 1 2 3 1 2 3 encrypted. On the desktop, let's overwrite this locked image, save it. Do you work? Yeah, you work. Locked image is locked. Let's select that locked image. Oops, we see the key here working properly. Let's decrypt it. Password is the wrong password. Oh, that's not handled. Yeah, I forgot to handle it. Okay, let's write the correct password, decrypted, select the locked password and save it. Yes, are you working? Right, it's working correctly. Now this guy is working. The reason we were getting error here, we were actually reading it in text mode, and when we are reading it in text mode, when we select an image, the content of that image is not actually the signature we're providing. Absolutely cannot be that. The content is in actually bytes array, not a simple string. So we had to specify a binary, and when we specify the binary, we have to write what are we going to do with it. We are creating it, we are writing to it, or whatever. as the error showed to us. We had to specify this switch as well. So now this is locked is also working. The last thing that I remember is the decrypt folder, the decrypt file, when we enter a wrong password, where we get the key. Yeah, here to get the key, fit key. Where is it being used? Here, exactly here. Here we have to do. Okay, let's see what error does it raise. Let's see what error it raises. Okay, select file. No, select a previously locked file, like this one. This guy does not have our signature before, because we locked it before implementing the signature process, so it's showing us the default icon, but no matter what. And we enter a wrong password, it will crash. Okay, this is the error we are facing. I wanted this one, I save it, I copy it, and I get here, come here, we try, we actually accept this error. Cryptography is not imported here. No, it's not imported here. Fairnet invalid token, but we can import it. Invalid token, so now we no longer need this part. If this happens, we can show message box, which we implemented in our window, parent window class. It needs a title and a text. The title is error, and the context, the text is password is wrong, please try again. And now I think it has to work. Let's see. Let's open the locked file again. Press decrypt, a wrong password, decrypt. Oops, got error. This get clear data, this replace. Okay, where is our try accept? Don't say that we did it in encrypt. Wow, why should the password be wrong when you're encrypting it? I'm sorry guys, I did a mistake. We reverted back. We have to do it in our decrypt module and get clear data. Sorry. And I copied that here. I press tab to bring these guys a little forward. Do a try here, and then I have to import this invalid token from Fairnet. Encrypt is no longer having that silly try accept. And select the locked file, decrypt, a wrong password, no longer a crash, password is wrong, please try again. Oops, when the password is wrong, you shouldn't let it to select. Okay, decrypt, get clear data, how to handle it. We can raise error. We could move this try except here or return none and handle it with an if clause. But I think this is better. It's better to move it down here, push this guy forward, get this guy here, try getting the clear data. If an invalid token raises, we show him the error and return. And get these guys back again. I think it's the better approach. We could return none here when we got try except, and make an if clause here. If clear data is none, then return or show, but that would make our code a little more, because we had to write the try except here and the if clause here. But when we can handle it with one of them, why not doing it? So I think this is a better approach, but I leave it to you if you want that approach. Okay, if I want to show you that approach, it would be like this. Let me copy it to have it. You could do something like this. Here, if clear data is none, you could show him a message here and return. This will get back here, and the try except will be written here, like what I written just some minutes ago. But I would rather to go with this approach, so I undo. Let's test it. I think it's better to test the whole application now from the beginning. Let's select a file to encrypt it. I'll go to my pictures, my wallpapers, and select this image. Press encrypt. 123 123. Let's test if the passwords do not match, what will happen. Encrypt. Passwords do not match. Beautiful. 123. Encrypt. We go to desktop. Final locked file. We save it. Final locked file. Let's import it. Final locked file turns into a lock. Sorry. We select it. We select final lock file. No, why did I do it again? We press decrypt. We enter 123 password. Let's first enter wrong password. Password is wrong. And 123 decrypt. Select the final locked folder, locked file, append .jpeg to it, and save it there. We see that, is it over here? Yeah, final locked file .jpeg is here. Where this? Yeah, final, yeah. This is the image we just locked. Well, I think the whole application is working properly. I want to add a margin to this layout. I forgot to add it. 8 pixel, 8 pixel, 8 pixel, 8 pixels, and save it. Let's import another file type, like for example, I don't have a PDF file. Yeah, I don't have a PDF file. I use this guy, encrypted 123 123 encrypt desktop, final locked file again. Yes, final locked file. Open that final locked file again. It turned into locked. And sorry, decrypted. Password 123, decrypt. Password is wrong. What did I enter? Come on. What did I enter then? I don't know. Let's see. Why is that? In the decrypt. Oh, you know guys, this encrypted data contains our signatures, so we have to replace it before decrypting it. Yeah, because as you saw, the signature was at the end of our logged file, so we have to replace it and then decrypt it. This guy works now. Let's continue. Let's continue where we left off. We were here selecting this final text logged file, press decrypt, press 1 to 3, press decrypt. Yeah, it's working. And I want to select this one and name it main as it was before and save it. Main, yeah, I thought you were going to write the extension as well, so let me do it again. Let me decrypt it again. 1 to 3, decrypt. I select this final text log file. This is a logged file, the content is not readable. We save it, we replace it, it opens it, and this one, the content should be readable now. We open it and we see, yeah, it's our code and it's a readable final text logged file. Thanks guys for watching the video. I put the code in GitHub in case you want to use the code or make any contributions. If you got any questions, suggestions or anything else, let me know in the comments. Take care.